In this video, I am going to share 5 incredible Raspberry Pi projects. Each one is unique, practical and shows just how powerful this tiny computer can be. Whether you are into tech experiments or building something useful, there is a project here you will want to try. So here we go. When people talk about single board computers, Raspberry Pi is the most preferred choice of everyone. Today I am having a Raspberry Pi 4 Model B with me and I gonna do an interesting project with it. I am going to make this to this. Yes, today I am going to make an Android Smart TV using our Raspberry Pi. Welcome guys, I am your host Jayanto and you are watching TechAreaNetwork. First let me arrange the hardware components for this project. Number 1, a Raspberry Pi 4 Model B along with the casing. Number 2, a 16GB class 10 microSD card with a card holder. If you have USB card reader, then it will also work. Number 3, a micro HDMI to HDMI cable. Micro HDMI goes to the Raspberry Pi and the HDMI end goes to your non-smart TV. Number 4, a 5V 3A USB Type-C power adapter for power. Number 5, keyboard and mouse. You can use wireless or wired, whatever you want. And number 6, a USB pen drive. Now let's go to my laptop. First download LineageOS 16.0 which is based on Android 9. You can download it from the developer's official website. Once the download has been done, insert the 16GB microSD card into the card holder and insert it into the laptop's built-in card reader, or you can use a USB card reader too. Here you can see a new flash drive has been detected in my laptop with a drive letter F. Now go to the download folder where the LineageOS 16.0 has been downloaded. So here it is. Let's now unzip or extract this file. After extracting, we can see a new image file of the LineageOS 16.0. Now let's flash this image file into the flash drive, and for that I am using Win32 disk imager. Let's now browse for the image file and my drive letter is F. Finally click on write. Once the flashing has been done, insert the SD card into your Raspberry Pi. Now we have to add the other hardware components like micro HDMI for display, the USB keyboard and mouse, and finally the Type-C power adapter to turn it on. So you can see the LEDs have started blinking. Let me show you the display now. Here we go. You can see that the LineageOS is booting here. This might take a few minutes to be completed. Once the booting process has been done, we will be moving to the setup wizard. Let's click on next, select the language and click on next. Here we will select the time zone, date and time. Then click on next, and here we have to connect to our Wi-Fi network. I will keep the location services default. Click on next. The LineageOS features would also be as default. You can skip this step. Now click on start. As you can see, the Android is successfully installed in your Raspberry Pi. Let's verify it once. Drag the mouse pointer from the top edge of your screen like we do in our smartphone. Then click on settings icon. Now go to the about section. As you can see that the Android version 9 is running here in this Raspberry Pi device. So we have successfully installed and set up the OS part. Still there are a few more steps to be done to make it as a smart TV. It is mandatorily required the Google Play service to be installed in every Android smart TV. So let's go back to my laptop. To avail the Google Play services in your TV, you need to have a package called G-Apps on your Raspberry Pi. And the most popular app in this regard is Pico package, which has the bare minimum Google Play service functionalities. You can download it from opengaps.org. So I have selected ARM, Android version 9, and the variant is Pico, and then click on download. Another tool we should have with us is called Recovery to Boot. So let's download it from Google. Once the download is finished, copy the G-Apps and Recovery to Boot, both the tools, into a pen drive. Let's now move on to the Raspberry Pi and open Settings. go to About, and then click on the build number 7 times to enable the developer option. Since the developer option is enabled, so let's go into the developer option. Here you have to root your Android device by enabling the root access from here. Now select Apps and ADB option. Click OK to confirm. After that, turn on the local terminal. So finally we have turned on the local terminal option from here. Now go back to the home screen. Since we have enabled the root access and the local terminal, we should get this terminal icon here. Now in the Raspberry Pi, insert the pen drive where I have copied the recovery to boot and GApps zip files and click on terminal. Click allow to continue. Now put the command su to enter into the super user mode. Now click on allow to move on. Now put the command rpi4 recovery.sh. Once you have entered this command, it will ask to reboot your Raspberry Pi device. I have used reboot command to reboot my Raspberry Pi device. As the pen drive is already inserted in our Raspberry Pi device, so after a couple of moments we will be landing on a recovery console. Now click on install button. Click on select storage to select our pen drive. In our case, USB OTG is our pen drive. So you can see the zip files which we have previously copied in our pen drive. Now select Open GApps. In this screen, swipe the slider to confirm flash. So right now GApps are getting installed. It might take a couple of minutes to complete. Once the installation is done, we need to click on Wipe Dalvik. Now swipe the slider to wipe. Now go back by clicking here. Now we are on the main recovery window. Let's click on Wipe button. Then swipe the slider to factory reset. Once it has been done, then go back to the main recovery console. Now click on Install and select Recovery to boot from the pen drive. Now swipe the slider to confirm the flash. As recovery to boot and GApps installed in this Raspberry Pi, so let's now reboot the system. Once the reboot process is done, we have to set up this Android device. This is just like what we do after purchasing a new Android smartphone. In this step, we will go with the default options, then click on Next. Finally click on Start. Now the interface is looking like an Android phone, but we need to have an Android Smart TV. To convert this, we need to install a launcher app called TV Home. Once the TV Home launcher app gets installed, I will have to choose the TV Home from here and set it as working always. Wow! Now we are in front of a smart TV. So this is how you can convert your normal LED TV to a smart TV using a Raspberry Pi. And believe me, I personally using this smart TV for a couple of months. However, you can additionally install the apps like Aptoide TV, Set Orientation, etc. to make the TV more user friendly. Anyway, let me try to install Amazon Prime Video from Google Play Store and play a web series for you. If you haven't found the installed apps in your Raspberry Pi Smart TV, then you can restart the Raspberry Pi device by holding the F5 key for a few seconds and restart or shut down whatever you want. So after restarting the Raspberry Pi, you can see that Amazon Prime Video is there in my all apps section. One of the most spoken words in today's world is hacking. And how it would be if you are given a hacking device which you can carry in your pocket? Well, I am going to give you that. But before it gets shipped to you, I am pretty much sure that you will build that yourself till then. Jokes apart. However, when we talk about hacking, rather ethical hacking, the most popular OS in this regard is Kali Linux. And today I am going to build a pocket-sized hacking device by using a Raspberry Pi device and Kali Linux. First, let's talk about the hardware requirements. Number 1, a Raspberry Pi 4 Model B with optional casing. Number 2, a USB Type-C power adapter. Number 3, a 16GB microSD card with a USB card reader, and it is recommended to use class 10 microSD card. And number 4, a microHDMI to HDMI cable for display. The microHDMI end goes to the Raspberry Pi and the HDMI end goes to your monitor. Now let's talk about the software requirements. First, download the 64-bit image file of Kali Linux for Raspberry Pi 4. You can get it from their official website offensivesecurity.com. Now let's download Balena for flashing the SD card with Kali Linux image file. You can download it as per your operating system or hardware architecture. Another tool we need to have with us is called 7-zip for extracting the Kali Linux image file. Here you can download 7-zip as per your operating system and the system architecture. After completing the download of all the required tools and softwares, now I am in the download folder of Kali Linux image file. You can see the image file is downloaded here. Now I have to extract the file by using 7-zip tool. After extracting the zip file, we have got a new folder in the same location. Let's go inside this folder. And you can see this is the actual image file of Kali Linux for Raspberry Pi 4. Meanwhile, I have already inserted my USB card reader along with the 16GB microSD card in my desktop. Let's now flash it using Balena tool. You can see that the 16GB microSD card has been detected by the software. Let's now browse for the Kali Linux image file to flash into the SD card. So this is the image file. Click on open. And finally click on flash. This will take some time to be completed. I will come back after flashing the SD card with the Kali Linux image file. Once the flashing has been done, take out the SD card from the card reader and insert it into the Raspberry Pi. Then attach the micro HDMI cable, keyboard, mouse, finally the USB Type-C power adapter with your Raspberry Pi. Now let's have a look on the booting process. Finally, we are on the login window. Here the default login username and password both are Kali. Let's now click on login. So this will be the basic profile after your first login to Kali Linux on Raspberry Pi. These are some pre-installed applications with the OS which we will use later. This is the file manager or file explorer. And this is the most preferred terminal of Kali Linux. Let's now try out some basic commands like who am I? It's Kali because I have logged in here as Kali user. So what's my present working directory? It's /home/Kali. Let's list the content of this directory. Now I will switch to root user. So I'll put the command sudo su and put the present password of the Kali user. Let's put the command who am I. As you can see that I have switched to root user. But my present working directory is /home/Kali. Let's change the directory to the home directory of the root user. Now let's put pwd. So you can see that I am on /root. That is the home directory of root user of this Kali Linux. Since the Raspberry Pi 4 Model B is having a inbuilt Wi-Fi adapter, so let's connect to my available Wi-Fi network. As my Raspberry Pi device is connected to internet, so let's do a ping test. So it's working now. Let's go to the web browser and browse some websites. Okay, let's open my own YouTube channel, that is youtube.com/TechAreaNetwork. As you can see that I am successfully connected to the internet and can browse my YouTube channel. Now we will do some advanced job on this device. As internet is working properly here, first I will update the packages by putting the command apt update. So after updating the packages, now let's check the Kali Linux version by putting the command uname -a. Now let's check the RAM status of this Raspberry Pi device. If you want to work on Metasploit framework, then you can use MSF console here. So right now we are on MSF console. Let's now exit from this console and look into the network configuration of this Raspberry Pi device. Now I will put the command iwconfig. So this is the network information of this Raspberry Pi device. As I am connected to my own Wi-Fi network, so you can see the status from WLAN 0 section. Now I am going to enable network monitoring service here. But before that, let's disconnect from the Wi-Fi networks. Let's open a console here and do a ping test to the global DNS. So finally, my Raspberry Pi device is not connected to the internet. Let's check the network configuration again. As you can see that WLAN 0 is disconnected status, as I am disconnected from my Wi-Fi network. Now I will put a new command called monstart to enable the network monitoring service here. As you can see, a new monitoring interface named WLAN 0 mon is available. Let's see some more details about the network configuration. So you can see that WLAN 0 mon is available and it's in monitor mode, and WLAN 0 is in disconnected state. It means now I can monitor my neighbor's Wi-Fi network details. For doing that, I have to put the command airo dump -ng, then the interface name, my monitoring interface name, that is WLAN 0 mon. So as you can see that now I can monitor my locality's other Wi-Fi networks, their hardware information and many more. And I am doing all this without connected to the internet or my own Wi-Fi router. Now I will stop the monitoring process by using the command monstop. Let's now execute iwconfig command to check the network information or network status of this device. So you can see that WLAN 0 mon or the monitoring interface is disabled and WLAN 0 is activated. Let's now connect to my own Wi-Fi router and then execute the command iwconfig to check the present network status. You can see that my device is connected to the Wi-Fi router and I can get the ping from my global DNS. Let's browse the internet. So before getting towards the main practical session of this video, let me show you the hardware requirement for this project. Number 1, a class 10 16GB microSD card with a card reader. If you have built-in card reader in your desktop or laptop, you don't need the USB card reader. Number 2, a Raspberry Pi along with the optional casing. I am using Raspberry Pi 4 Model B in this video. Number 3, a micro HDMI to HDMI cable. Number 4, a 5V 3A USB Type-C power adapter for power. And number 5, USB keyboard and mouse. In the description box below, you will get all the links of the gadgets used in this video. You can check these out if you want. Before performing the installation, you should know 3 important points. Number 1, you should have a stable internet connection. Number 2, you should have enough free hard disk space in your laptop or desktop. And last but not the least, which is very important, make sure you have liked and shared the video and subscribed the channel as well. So I am on my Dell Inspiron 3593 laptop. It is powered by Intel Core i3 10th generation processor with 8 gigs of RAM. It is also having one SSD and one SATA hard drive with good amount of free space. If you don't have such a powerful configuration, don't worry, you can still perform the installation. You just have to make sure that you have enough free hard disk space and a stable internet connection. So we are going to perform the step 1 now. First, let's open a web browser and go to a site called worproject.ml. This website or project is basically a repository of Windows images for Raspberry Pi device. You can get various Windows versions for different Raspberry Pi models or versions. Now go to the download section. Here you will get various links to download various tools. But we will need only 2 download links to install Windows 11 on a Raspberry Pi. From the Windows on Raspberry Imager section, we will download a tool which will help us to flash the Windows 11 image in our microSD card. After downloading the Windows image flashing tool, we will go to the Windows Images section to download the Windows 11 image. Click on Getting Windows Images link. Here you will get all the steps to download the Windows ISO image. In step 1, you will find a website link called uupdump.net. Let's go to the site. From this website, you will actually get the Windows images for your Raspberry Pi. If you scroll down, you will find various Windows versions. But as we are going to install Windows 11 in our Raspberry Pi only, so we will click on this link. Before clicking on the link, please make sure ARM64 is written beside your link because Raspberry Pi is a single board computer and it always works on ARM based processor architecture. So a wizard has been opened up. Click on Next. Here you will get Windows 11 Home and Pro, both the versions. You can select both or you can select any one of the versions. I will select the Pro version only to reduce the download time. In this step, keep the settings as default and click on Create Download Package. This will download a zip file in your system, not the Windows 11 ISO. Actually, this tool will download the Windows 11 installation files and convert these to an ISO file. Let's now go to the downloads folder. Here we are getting 2 zip files. WOR_release file is the tool which will help us to flash the ISO image to our SD card. Another zip file is the tool which will help us to download the Windows 11 image file. Let's extract it. Here you will have to run this file to download the Windows 11 ISO image for Raspberry Pi. After executing the tool, you will have to wait for at least 20 to 25 minutes depending upon your internet speed. This is an unattended process. I will be right back after completing the process. Finally, you have to press 0 to finish the process and you are done. So this is the ISO image for Windows 11 for the Raspberry Pi. We will flash this file to our SD card. But before that, let's insert the microSD card in the card reader slot. After that, I will format the SD card by SD card formatter tool. Now we will extract the image builder tool. By this tool, we will flash the Windows 11 ISO image to our SD card. Now run this exe file, a wizard will come up. You can keep the settings default here and click on Next. Now in the storage drive drop down list, I am getting all the storage drives of my laptop, which includes the SD card and the internal hard disks also. Here you should make sure you have selected the SD card only, otherwise it will format your internal hard disk. In the device type section, you can select your Raspberry Pi model or version. I will select this because I am using Raspberry Pi 4 Model B. Then click on Next. Now we have to browse for the Windows 11 ISO file, which we have downloaded in the earlier step. It has automatically detected the version here. Now click on Next. And finally click on Install to flash the Windows 11 in your SD card. This will take some time. I will be back here once it gets completed. So all done. Now I will remove the SD card from my laptop and insert it to the Raspberry Pi. Then place it on the casing. Then plug the USB keyboard and mouse. Then the micro HDMI cable. Then the internet wire. Finally the USB Type-C power adapter. Before powering on the device, make sure you have plugged in all the required components. So we are getting the Raspberry Pi logo on our monitor and the loading bar is gradually progressing. Now the first time booting process can take longer time to complete and it might be restarted couple of times during the process. So I am fast forwarding the video now. Finally, we are on the desktop of Windows 11, which is actually running on a Raspberry Pi. Let's have a look on the processor and RAM information. So you can see that it's an ARM Cortex A72 processor with 4 gigs of RAM. We can get many settings from here like network info and all that. That's all for today. Hope you have enjoyed the video. Thanks for staying with us.
Hi guys, this is Jonathan and you are watching TechAreaNetwork. Today I am on another awesome project with my favorite Raspberry Pi. Today in this session I will show you how to block internet ads in all your smart gadgets like smartphones, iPhones, tabs, laptop, desktop or whatever the gadget you have in your network by using a single Raspberry Pi. This will definitely boost up your network speed and the productivity as well, especially when you are on work from home model. Before moving to the practical session, please make sure you have subscribed to our channel, hit the bell icons for all video notifications and don't forget to like, share and comment.
Here we will use a network tracker and ad blocker tool known as Pi-hole. This works as a DNS server for your network and blocks the ads at the DNS level. As a traditional practice, we usually use ad blocker tools in the web browser level of all the available devices in our network. If any new device or guest device comes up, we have to configure the device to block the ads. So this is a kind of manual task which has to be eliminated. That's why we will use Pi-hole, and most importantly, it's an open source product. So we're gonna deploy this awesome tool on a Raspberry Pi 4. You can visit my Raspberry Pi DIY project playlist for more such beautiful videos. Now let's talk about the hardware requirement for this project. Number 1, Raspberry Pi. In my case, I am using Raspberry Pi 4 Model B with optional casing. Number 2, a 16GB microSD card with a card holder or card reader. Make sure you are having class 10 microSD card. Number 3, a micro HDMI to HDMI cable for display. And number 4, USB Type-C power adapter for power supply. Now let's talk about the software requirements. We will need to download the Raspbian OS from their official website. I'll put the link in the description box below. After downloading the OS image, we will have to flash it to the SD card. For that, we will use Etcher tool. You can use any other tool of your choice. Right now we are going to download the Raspbian OS. So the download process has been started. I will be back after completing the download. As Etcher tool was pre-installed in my system, so I will directly open the Etcher tool from start menu. And meanwhile, I have inserted the USB card reader with the SD card into my system. So you can see that 16GB microSD card has been detected automatically by the Etcher tool. Now it's time to flash the downloaded image file into this SD card. Let's click here to browse the image file. So here is the downloaded Raspbian OS image file. Let's select it and click on open. Then click on flash to flash the image file into the SD card. This might take a few minutes to complete, so I'll be back after completing the process. So after completing the process, we will need to insert the SD card into the Raspberry Pi 4. Attach the other components like HDMI cable, keyboard, mouse to it, and finally turn it on. So this is the home profile after booting Raspbian OS on Raspberry Pi. Now we will have to do some basic jobs like connecting to the internet via wire or Wi-Fi, whatever you want. You can also set up SSH to connect the device remotely. Here I am using my Wi-Fi network for internet connectivity. Let's now check the IP address which is assigned by my router to this Raspberry Pi 4. So it's 192.168.1.8. If I do a ping test toward the internet, I can get it too. So my device is reachable to the internet. Now let's start the main part of the session. As I told about Pi-hole ad blocker tool earlier in this video, now it's the time to install Pi-hole in this Raspberry Pi device. So use this command to make an automated installation of Pi-hole. Don't worry, I will put the command in the description box below. So the command has been initiated successfully, and this might take a few minutes to be completed. As you can see, the wizard itself is telling me that this will make this device to a network-wide ad blocker. So I should say OK. Since Pi-hole is an open source tool, you can support them by making some donations. Press enter to proceed to the next window. In this step, the assigned dynamic IP address, that is 192.168.1.8 to this Raspberry Pi would be saved as the static one, because it will work as an ad blocking server and we don't want our server to change that IP address dynamically. Press enter to proceed to the next window. In this step, we have to select our Raspberry Pi's network interface card, which will be connected to the internet always. In my case, it would be the Wi-Fi NIC or WLAN 0 of my Raspberry Pi 4 device. Select WLAN 0 and press enter to proceed to the next window. Here we have to choose the global DNS service providers such as Google DNS or OpenDNS, or if you have any custom DNS server in your infrastructure, then you can choose custom DNS. I will go for OpenDNS here. Now these are some third-party ad blocking service providers. You can use these providers because Pi-hole has trust on them. Select all the providers and press OK to proceed further. Here I will select IPv4 and IPv6, both the protocols. Finally, it is asking me to use 192.168.1.8 as a static IP of this ad blocking server, and 192.168.1.1 as the gateway or IP address of my Wi-Fi router. I will confirm it by selecting yes. Before proceeding to the next step, make sure you don't assign the IP address 192.168.1.8 to any other device in your network. Otherwise, it may occur IP conflict issue. In this step, select on option to install a web admin interface because Pi-hole can be managed via web browser. This step is asking me to install the web server. Select on option to perform the step. In this step, it is asking me to log all the queries. Yes, I want to log the queries of all the devices in my network. So I will select on and press OK. This step is about the privacy mode. For now, I will select show everything. Whatever the settings I have done so far can be edited later as per the requirements. So the options we have selected in the previous steps are now started. This may take a few minutes to be completed. I will be right back once all the tasks get finished. Finally, the setup is ready for us. Here is the IP address of this ad blocker. This is the web interface to log in and manage the network, and this is the password to login. Firstly, I will change the login password of the web interface. For that, I will use this command. Now I will set my new password. You can also set a blank password too. Now let's verify the IP address of this device once. It should be 192.168.1.8. Okay, let's now go to my laptop to open the dashboard of this ad blocker device remotely. So right now I am on my laptop and my web browser is also opened up. Now put the web interface address of the Raspberry Pi ad blocker. In my case, the URL is 192.168.1.8/admin. So this is the welcome page of the ad blocker device. Some basic information of the device and the network are being seen here. Now we will log into the device from here. I will put the password which I have set in the previous step. So there are lots of tabs are available to configure and monitor the network, such as query log, whitelist, blacklist, local DNS records and many more. If we go back to the dashboard, we can see that the ad blocker device is not detecting anything here. It means the ad blocker device presently is not in action. Before making it workable for our network, let's open a website that shows lots of ads. So guys, you can see lots of ads are being displayed here. To block all these ads, let's now configure our network's DNS part to point to the Raspberry Pi ad blocker. Because in this entire project, your ad blocker server will act as the DNS server for your network. You have two options here. Number one is go to your router's DHCP configuration and put the Raspberry Pi's IP address as the DNS server. Some home routers do not support this operation. In that case, you have to edit the DNS configuration in all the available devices in your network. I will show you that on my laptop and on an Android smartphone. Let's start with the laptop. Go to the network properties of the laptop. This is my Wi-Fi adapter by which I am connected to the internet. Let's go to the TCP/IP v4 properties of it. Put the DNS server IP address as 192.168.1.8, which is the IP address of my ad blocker server. That's all to do. Let's now go back to the website and refresh the page again. Wow, you can see that no ads at all. Let's now try another site. Very nice. So the ad blocker server is working properly for my laptop. Let's now go back to the ad blocker's dashboard. You can see the summarized logs of all the blocked queries here. For a detailed view, go to the query log. So this is the detailed log of the blocked queries from my laptop because as of now I have connected my laptop only. From here or from this window, you can convert a blacklisted domain to whitelist and whitelisted domain to blacklist. A lot more things can be done from this web management console. Like if you want to disable this ad blocker service temporarily or permanently in your network, you can do so. As I have stopped the service for 10 seconds only, so the ads will be started to display. After 10 seconds, the service will be resumed again automatically. You can stop the service permanently by clicking on indefinitely. Let's now try it on an Android phone. But remember guys, changing the DNS server IP in all the available gadgets only be required for those whose Wi-Fi routers don't allow to change it in the router level. Now I am on an Android smartphone. Go to the Wi-Fi settings of the Android device, select the desired Wi-Fi connection name and then configure it like this way. Tap on Show Advanced option. Change the IP settings from dynamic to static. Put the IP address, gateway, subnet mask as per your Wi-Fi network. And finally set the DNS server as the IP address of your ad blocking server. In my case it must be 192.168.1.8 and then followed by an optional global DNS server. Finally put your Wi-Fi password to connect to the Wi-Fi network. Finally I am connected to my Wi-Fi network. Let's open a website from here. So guys, you can see that no ads are being displayed here. Let's now check some more websites from this Android smartphone. So there is no ads so far. Finally, I am working on a network where there is no ads to slow down my internet bandwidth. Meanwhile, let's take a look on the ad blocker dashboard. It must contain a new device that is an Android smartphone and the IP must be 192.168.1.128, which I have set in the Wi-Fi properties of that smartphone. Here we go. So these are the queries which I have made from my smartphone. By this way you can monitor all the DNS queries generated from all the available gadgets in your network, and most importantly you can block all the ads to make the network faster. Hope you guys enjoyed the video. I want you to build such an awesome ad blocker at your place and share your experience in the comment section. And don't forget to like, share and subscribe the channel for more such awesome projects. The most valuable thing in today's world is data. Even at our home, we regularly generate data by using our smartphones, laptops, cameras and many such gadgets. So regular data backup becomes an essential job in our daily life, and today I gonna do a project on that. Today I will build a NAS or network attached storage device by using a Raspberry Pi with a very low budget. Not only that, today's video will also cover the redundancy of your data so that you will never lose your precious data at all, even after your storage unit of the NAS device gets damaged. Hi, this is Jayanto and you are watching TechAreaNetwork. Now let's talk about the hardware requirement of this project. Number one, we can build this project on Raspberry Pi 3 or 3B or 4 or whatever we want. I am using Raspberry Pi 4 Model B here. Number two, since we will be building RAID array, so it requires to have at least 2 hard drives. I will recommend you to use 2 USB 3.0 hard drives with 1 TB of storage capacity each. Even you can use SSD or SATA hard drive, but make sure to arrange additional power resources for the hard drives. Since it is a tutorial video, so I will have to complete the session within a minimum possible time. That's why I will use 2 USB pen drives with 4 GB of storage capacity each. Two more things we should have with us are one class 10 micro SD card with at least 16 GB storage capacity and a card reader. Right now I am on my Windows desktop, and from here I will download Raspbian OS from the official website of Raspberry Pi. I will put the link in the description box below. So here we have 3 image files to download. I will download the first one because it contains the desktop environment along with the additional softwares. It will take time to complete the download process depending upon your internet speed. I will come back after downloading the image file. So I am back after downloading the image file. Meanwhile, I have inserted the USB card reader with 16 GB micro SD card in my Windows 10 PC. Now I will flash the 16 GB micro SD card with the Raspbian image by using Balena HR. As you can see, the 16 GB micro SD card has been detected by the Balena HR software itself. Now let's click on Flash from File and I will browse for the downloaded image file of Raspbian OS. So this is the downloaded image file of Raspbian OS. Let's select this and click on Open. Finally click on Flash. This might take some time to complete. I will come back after completing the process. So the SD card is ready. Now I will insert the card in Raspberry Pi and connect monitor, keyboard, mouse and power on the Raspberry Pi device. So this is the interface of Raspbian OS and I have opened up the terminal here. As the Raspberry Pi 4 Model B has the built-in Wi-Fi network adapter, so I have connected the device to my home Wi-Fi router to get the internet. You can use the wired connection too. Before going to the main configuration part, I will highly recommend you to run these two commands. Number one, sudo apt-get space update and then sudo apt-get space then upgrade. these two commands will update the list of available packages and their versions, and then install or upgrade the packages. Now it's time to start the main configuration. I have inserted both the USB pen drives in this Raspberry Pi device. Now I will need a partitioning tool. So I will install a package called gparted. After the installation, let's open the package by putting the command sudo gparted. So we have got a graphical interface of gparted for partitioning the storage units. Here you will find the storage units which are attached with this Raspberry Pi device. Number 1 /dev/mmcblk0. This is the 16 GB micro SD card on which we have installed the Raspbian OS. So we have nothing to do with this one. Number 2 /dev/sda. This is representing the first 4 GB pen drive, and number 3 /dev/sdb. This is representing the second 4 GB pen drive. So the last two drives will be our working drives to build the NAS. As this is a tutorial video, so I am using the 4 GB pen drives to complete the video within a minimum time period. You can use 1 TB, 2 TB, 4 TB or whatever you want for using the NAS device in the real life. Now let's select the first 4 GB storage unit. As I did the testing earlier, so here you are getting the file system as Linux RAID. Let me delete the partition and then repartitioning the unit once again. Select this and click here to delete the volume. Click here to apply or confirm. Click on apply. Okay, now click here to make a new partition on /dev/sda, which is my first 4 GB pen drive. Make sure you are going with the default values which are being seen here. And then click on add. And finally confirm the settings by clicking the tick button. Click on apply. So we are done with our first storage unit of the NAS device. Let's now do the same things for the second 4 GB storage unit, that is /dev/sdb. See, all the buttons to create a new partition are disabled here. If you have faced the issue like me, then just go to the partition menu and click on unmount. Now it's good to carry on the partition process. Do the same thing what we have done for the first one. So the partitioning operation on our storage units of the NAS device has been done. As we need the redundancy so that we will never lose our valuable data at all, so we will have to configure software RAID by using the package called mdadm. So let's now install it. I will use the command sudo apt-get install, then mdadm. Now we will have to install another package called Samba. For Samba, we actually need two packages. Number 1, Samba itself, and number 2, Samba-common-bin. Before starting the RAID configuration, let's check the storage unit's status by using the command sudo space blkid. So you can see both of the storage units of our NAS device, that is /dev/sda1 and /dev/sdb1. Now let's configure the RAID. So I'll put sudo mdadm --create --verbose, then put a new path of the RAID volume. I am defining it as /dev/md1. Then --level, I will go for the RAID 10, so I will put 10 as my level. Then the RAID devices, I will use 2 storage units for this RAID. Then put the path of the storage units. One is /dev/sda1 and another is /dev/sdb1. Because we are going to build this NAS device by using these two 4GB storage units. Press enter to execute. Now it is asking me to confirm the creating the array. Now I will put Y to confirm it. Okay, the RAID array has been started. Let's now check the status. For that, we will use this command cat/proc/mdstat. As you can see, the resyncing process is going on and it is at 1.9%. It means it is synchronizing the two drives to make sure the RAID volume gets lined up properly. It may take times depending upon the storage capacity of your drives. But we can go ahead with this. Let's put this command to save all these settings in mdadm config file. Okay, this command should be run by the root user itself. So I will put sudo space -i to switch to the root user. Now put the command again. Now the command has been executed successfully. Now to verify it, let's see the last, let's say 10 lines of /etc/mdadm/mdadm.conf file. Now look at the last line where you should get the information about the RAID array with the RAID drive, that is /dev/md1. So it has been saved successfully in the mdadm configuration file. It means the RAID array will not be broken even if you have rebooted the Raspberry Pi device. Let's now go back to the Pi user login. Now we are going to create an ext4 file system on this RAID volume. This will make the volume accessible for storing data. For that, put this command. Once it gets done, try to mount the RAID volume, that is /dev/md1 temporarily, and I am mounting it on /mnt. Let's now list the content of /mnt directory. So only one default directory, that is lost and found, which usually comes with the RAID volume, is there. So it means the RAID volume has been mounted on /mnt directory. Let's now unmount it, because I want to make a permanent mount point for this RAID volume. Now I will create a directory under root, and it will be named as /rpi_nas, and it will be my permanent mount point of the RAID volume. Once the directory has been made, I will now mount our RAID volume, that is /dev/md1 on it. So I will put the command sudo mount, then the RAID volume name, in my case it is /dev/md1, and then the mount point, that is /rpi_nas. So the command has been executed without any error. Let's list the content of /rpi_nas. It must contain lost and found directory. So the mounting process has been done successfully. Let's now check the storage status of this Raspberry Pi device by using the command sudo df-h. You should find the newly created RAID volume here. So here it is. The volume name is /dev/md1. The usable size is almost 4 GB because we have built the mirroring RAID and it is mounted on /rpi_nas directory. Let's now make the mount point permanent so that we will never lose the mount point even after we reboot the Raspberry Pi device, rather the NAS storage device. So I will edit the file called etc/fstab, and here I will make this entry. So finally save and close this file by pressing Ctrl O and Ctrl X. So it's done now. Let me check the resyncing status of the RAID volume again. So let's open cat/proc/mdstat. So you can see that now we are at 52.9%. Meantime, we will configure Samba because we will be going to save our data here over the network from other laptops, smartphones and any other gadgets. Firstly, we will set a new Samba password for a user. I have logged in here as a user Pi. Let's configure this Pi user as a Samba user. You can create any other user and configure that user as a Samba user. Make a note here that the Samba password will be used when we will access the RAID volume over the network only. So I have set a new Samba password for Pi user, and which is different from the login password of Pi to this Raspberry Pi device. Now open the Samba configuration file, that is /etc/samba/smb.conf. Go to the bottom of this file and add these lines. Finally save and close this file by pressing Ctrl O and Ctrl X. Let's now verify whether the Samba configuration is correct by using the command test_perm. As you can see, all the services are loaded successfully and our configuration is good to go. Let's now restart the Samba service. Sudo systemctl restart smbd.service. Let's check the status. Sudo systemctl status smbd.service. So you can see it's active and running. Now we will need to change the ownership of our mount point, that is /rpi_nas directory. We need the Pi user to have the ownership on this directory. Now it is owned by the root user. You can see the status or ownership properties of this folder /rpi_nas, and it is clearly mentioned that it is owned by the root user. Put this command to change the ownership. Sudo space chown -R space the username, that is Pi, and the mount point name, that is /rpi_nas. Let's again check the properties of /rpi_nas. So the ownership given to the user Pi. So we are done. Now is the time to test our NAS device from the other gadgets over the network. But before that, let's check the IP address of this NAS device. In my case, it's 192.168.1.7. Let's now go to my laptop and access the NAS device. From my laptop, I will open run and put /192.168.1.7. Wow, I can see the read volume of the Raspberry Pi device. Let's now open it. As expected, I will have to pass the authentication and I will use the Samba user ID and password. In my case, the Samba user ID was Pi. So I can see the content of my read volume. Let's now put some files or folders here from my laptop. To verify whether the files are stored in our NAS device, go back to the Raspberry Pi and list the content of the mount point. In my case, it was /RPI_NAS. So we can see the same content which we have stored from our laptop. So it means we are saving our files or data in the right NAS device over the network. One more thing I will do here, I will map this NAS device as a network drive in my laptop so that we can get the drive from my computer. So guys, I hope you have enjoyed the video. Please check out the description below for more exciting stuffs and don't forget to subscribe, share and comment. Thanks for watching the video.